this is kind of our graph that we're dealing with. This little region, that's what we found the area of in Part A. Part B asks us to find the volume of the solid form. This region is rotated around the x-axis. So if we spin this around the x-axis, what is our volume? So first, we need to figure out, is this a dx cut or a dy cut? Dx, right? It's top minus bottom. So we're looking at a dx cut. So if we take this little rectangle and spin it around that axis, so here's our axis of revolution, here's our rectangle. If we spin that around, we end up getting a washer. Alright, so washer, remember, is going to be pi times definite integral from a to b of big radius squared minus little radius squared times dx. So if we're looking at this, that's our little radius, that's our big radius. So kind of transferring it to here, little radius goes to that parabola. Big radius goes to our e to the cosine of x. So e to the cosine of x, that's our big radius, that was y sub 1. And our little radius is going to be y sub 2. And we already know we're going from 0 to b, which we already calculated at 1.199. So we can set up our definite integral. We're going to have pi times the definite integral from 0 to b. Now, if we were doing this free response, you would want to do one of two things. Either put in like that 3 decimal approximation, the 1.199, or at some point, if you say b equals 1.119, you can just write it as b, as long as you have it labeled somewhere. So from 0 to b, and we're doing y sub 1 squared minus y sub 2 squared dx. So we're going to do pi first, and then we're going to do math 9. We're going from 0 to b, and this one is y sub 1 squared, and that all depends on the graph. It could be something else. You just have to kind of look at how it's set up. We have y sub 1 squared minus y sub 2 squared, and then we're doing this in terms of x. So you should get 17.529.